Let's begin the new chapter, gravitation. Ninth standard physics revolves around the concept of motion. In this chapter, we will study motion of the objects under the influence of gravitational force. The saga of gravitation begins with this picture. All of you know very well the phenomenon of gravitation was first discovered by scientist Sir Isaac Newton. As the story goes, he discovered force of gravitation by seeing an apple fall from a tree on the ground. He wondered why all the apples, other fruits, leaves, flowers, and every other object falls vertically downward. After much thinking, he concluded all these objects are getting attracted towards the earth, and this force of attraction must be directed towards the center of the earth. After further thinking, he stated not only earth exert force of attraction towards all these objects, but these objects also exert same amount of force of attraction towards the earth. In previous chapter, you have already studied Newton's third law of motion, right? For every action, there is equal, opposite and instantaneous reaction. So not only earth exerts force of attraction on all these objects, but these objects also exert same amount of force of attraction towards the earth or on the earth. But the earth does not move towards these objects, although these objects also exert force of attraction on the earth. Think why? Yes, because of its enormous mass. This force of attraction is not enough for the earth to move. Newton further kept pondering and toying around this idea of gravitational force of attraction between earth and different objects around it. Later, he generalized the concept by saying not only there is a force of attraction between the earth and different objects on it, but every object attracts every other object. So, according to Newton, every object in this universe or which is a part of this universe attracts every other object with a certain amount of force, and this force is called as gravitational force. Gravitational force between two objects, any two objects, act even if the two objects are not connected by any mean. So, what is this gravitation? It is nothing but the force of attraction that exists between any two objects. By applying little logic and based on his own observations, Newton further concluded that if masses of the two objects are small, then the gravitational force between them is also very small, which even cannot be detected or whose effect cannot be experienced. For example, let us talk about the two stones lying on the ground. Suppose these two stones are very small and their masses are negligible or very small. Then there exists force of attraction between these two stones, but the magnitude of force of attraction is very small, and as a result these two stones will not get attracted towards each other, or the effect of this force of attraction cannot be seen. Then Newton studied observations and conclusions drawn by several other scientists, particularly the scientists like Kepler, and he stated not only this force of attraction between the two objects depend upon mass, but it depends upon the distance between their centers. And based on these two things, these two conclusions, Newton formulated one very famous law that is called as universal law of gravitation. What is the statement of this universal law of gravitation? Every object in the universe attracts every other object with a definite force, which is directly proportional to product of their masses, and inversely proportional to square of distance between their centers. So, by this time, you people must have understood that yes, there exists force of attraction between any two objects which are the part of this universe. But let us figure out now how to find out magnitude of this force of attraction between these two objects. For that, let us take the use or let us consider this diagram. Let us consider one object having mass m1 and another object having mass m2. The distance between their centers is r. So let us find out the magnitude of force that exists between them. For that, let us take the help of universal law of gravitation. According to universal law of gravitation, the force of gravitation that exists between any two objects is directly proportional to product of their masses. So here masses are m1 and m2. Product is m1 multiplied by m2. So force of attraction is directly proportional to m1 m2. Then the latter part of universal law of gravitation, the force of attraction between any two objects is inversely proportional to square of distance between their centers. Here r is the distance between the centers of these two objects. So force of gravity is inversely proportional to distance between their centers, that is F proportional to 1 upon r square. Let us combine these two equations, and after combining these two equations we will get F is proportional to m1 m2 upon r square. Whenever you want to convert any expression into equation, what do? Yes, we have to introduce one proportionality constant. So here we will use the alphabet G as proportionality constant. F is equal to G, capital G of course, because it has certain significance. We will talk about this capital G in detail later. Okay. So right now you have to understand one thing, that this G is nothing but proportionality constant. So F is equal to G m1 m2 upon r square. So this is the formula with which you can calculate the force of gravitational attraction that exists between any two objects which are the part of this universe. Now let us talk about this proportionality constant capital G. It has to be strictly written in capital letters, as small g has some other significance about which we will learn very shortly. So let us rearrange the terms in the formula. F is equal to G m1 m2 upon r square. Instead of writing m1 m2, you can even write down capital M and small m also, indicating masses of two objects under discussion. So, after rearranging the terms, you will get Fr square upon m1 m2. Using this formula, one can find out value of universal constant of gravitation. So, how to find out that value? Let us consider if there are two objects having unit masses. Unit masses means 1 kg mass, and the distance between their centers is 1 meter. Now look at the formula. G is equal to Fr square upon m1 m2. Here the distance between them is 1 meter. So r square will become 1 square, that is 1, and m1 m2 unit masses these objects have. So unit masses means 1 kg mass. So 1 multiplied by 1, that is also 1. So F multiplied by 1 divided by 1. So here we will get G is equal to F. So in such a case, when we are talking about the objects having unit masses and the distance between their centers is 1 meter, then the force, that is gravitational force that exists between these two objects is equal to this universal constant of gravitation. its value is already calculated by famous scientist Henry Cavendish. In SI system, its value is 6.67 into 10 raised to minus 11. Now think about its unit. What will be its unit? Now see, look at the formula again. Fr square upon m1 m2. F means force which is to be measured in newtons. R is the distance, so it is to be measured in meters. So Newton meter square upon m is mass, right? So kg multiplied by kg, that is kg square. So SI unit for this universal constant of gravitation is Newton meter square upon kg square, and its value in SI system is 6.67 into 10 raised to minus 11 Newton meters upon kg square. Now its other unit, small unit, is Dine centimeter square upon gram square. In true sense, this universal constant of gravitation is constant term. Its value remains same everywhere.